In this video, we'll be talking about place value. We'll investigate numbers in our base 10 number system and also look at other bases. First, what is place value? Place value is the numerical value that a digit has based on its position within a number. Having a strong understanding of place value is key to understanding much of the mathematics that we teach in elementary school. Let's start with our own base 10 number system. So we're base 10, and we think about the symbols that we're allowed to use. There are 10 symbols starting with 0. In our base 10 number system, it's really important to know that we're working with a group size of 10. If we wanted to represent a number like 12, with a collection of objects, we would not choose to represent it like this, with 3 dots, because the 1 doesn't actually represent one unit. The 1 represents one group of 10. Let's go ahead and build some numbers in base 10 using unifix cubes. In base 10, the first 9 numbers are pretty straightforward. Every time we add a new unifix cube, we record a new number using the next numeral in our list of available numerals. After the number 9, we have to be careful. Adding one more unifix cube gives us 10 cubes, but we can't record 10 in the unit's place. We're only allowed to put one symbol, not 2 symbols. So what we do is we group all 10 together. Our group size is 10, remember, and once we have 10, we form them into a single group. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in our group. So we record one group of 10 and no units. Then we can continue on adding one unifix cube at a time and recording one new numeral in the units place. And again, when we add one more cube, we now have a new group of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A second group of 10. So we record 2 groups of 10 and no units. Most of us don't have to think very hard at this point in our math journey about the fact that this 1 in the number 12 isn't one unit, but it's actually 1 10, or in other words, one group of 10. Let's look at another base. One reason for doing this is because base 10 has become so second nature to us, it's hard to relate to students who are just figuring it out for the first time. So let's put ourselves in the place of figuring out some numbers for the first time, but now we're not going to do base 10. Base 10, we probably use it because we have 10 fingers. Let's pretend we don't have 10 fingers. Phineas, for example, on the right here, only has 4 fingers on a hand. We're going to count in base 4 as if Phineas was using one hand to count. So we have 4 numerals available to us, always starting at 0, 0, 1, 2, 3. So those are our 4 numerals, 0 to 3, and our group size, since we're in base 4, will be every 4 units. Now this can get a little bit awkward because we have our language based around base 10, so we'll have to be a little careful how we talk about things. Just like getting to 9 was easy in base 10, getting to 3 is easy in base 4. In base 4, when we add another unit here, we now have a set of 4. And once we have a set of 4 or a group of 4, we combine them into one group. And we record that the next place over. The 1 now no longer means one group of 10, it means one group of 4, and we have no units. This was important because in base 4, after the number 3, we don't have a new symbol, so there was nothing else we could have written in the units place except 0, 1, 2, and 3, and so we had to group together as a set of 4. It's easy again to add in the next 3 units. Adding one more gives us a new set of 4, so we group them together, and now we have 2 groups of 4 and 0 units. Let's fast forward until we have 3 groups of 4 and 3 units. Now, as we add one more, we again can group the 3 units together to form one group of 4. But what we notice is that we now have 4 groups of 4. So these 4 identical sets we can merge together. And now we have a set of 4 by 4. So now we're in the next place over, where a 1 in that location means one set of 4 by 4. Now we have no groups of 4 and no units. We could keep going where we add one unifix cube at a time, and we record our numbers such that we show how many units we have, how many groups of 4, and then we get this square shape, which was 4 groups of 4. Once we had 4 of these squares, we could stack them on top of each other, and we'd have a cube that was 4 by 4 by 4 in a new place. And this could keep going as long as we want to. Every time we have new groups of 4, we combine them. When we work in any base that's not base 10, it's standard to identify the base that we're using by writing a subscript to the right of the number with written out in letters the base. So 1, 2, 3, base 4, because this is here, we know we're not working in base 10. Let's go ahead and represent this. So the 3 right here, the place value, we know that this represents 3 units. So I'm going to just shade in 3 boxes. Grid paper works great for representing numbers in other bases. Then I come to the next place. The 2 doesn't mean 2 units. This means 2 groups. 2 groups of what? Well, we're in base 4, so 2 groups of 4. So here I'm going to shade in 1, 2, 3, 4. There's one group of 4, and here's a second group of 4. And then finally, we come to the next place over, and so now we know that we have groups of 4 by 4. So that means I have one group that's 4 units by 4 units. So that comes from one group of 4, a second group of 4, a third group of 4, and a fourth group of 4. This is our 4 by 4. So we have one 4 by 4, or 4 squared. We have 2 4 by 1s, or 4 to the first power, and we have 3 individual units. And that's just 4 to the 0th power right there. We can add and subtract. We can see that if we were to add 1, if we were to want to know what the next number is, well, the next number I'd add 1 unit, but then I'd have to group these guys together, and then suddenly they get promoted to be a group of 4. So the next unit over, the next number over, would be 1, 3, 0 in base 4, indicating that we have one 4 by 4. We have 3 groups of 4, or 4 by 1s, and then we have no individual units.